Hello, welcome to more practice of combining area of triangles today. So we're looking at using the distributive property to find the area, okay? So what are a few different ways we could write this? We could see this as a rectangle of 1, 2, 3, 4, 5, 5 times 4, right? Or we could think of it as 1 times 4 plus a rectangle of 4 times 4. Or we could think of it as a rectangle of 2 by 4 plus 3 by 4. Okay? Or we could think of it as 1 by 4 plus 1 by 4 plus 1 by 4 plus 1 by 4. You see, there's a few different ways we could split this up. So this problem, the best way to do it is looking at the answer choices. Let's see which of these makes the most sense. So if we did cover this up maybe one at a time here. So 4 by 4 and 4 by 3 would be two rectangles that they're making. So if I take 1, 2, 3 by 4 and 4 by 4, okay, that would satisfy this portion here, this rectangle, 4 by 4 rectangle, and then 4 by 3. Would that make sense? Is there enough? How many more columns do we have? Only one. So we would, to make this true, there would need to be a 4 by 4 rectangle and a 4 by 3 columns rectangle. So we know that that's not an option. How about this this one, 4 by 4? Okay, so similar case. If we broke this into a 4 by 4 rectangle, do we have 4 more columns to make another 4 by 4 rectangle? We don't, do we? Let's try this one. What if we did a 4 by 2 rectangle? So there's our 4 by 2 rectangle. Do we have enough columns to split this into another 4 by 5 rectangle? We don't. We would need 5 columns, not the 1, 2, 3 columns we have left. How about this one? What if we split it into a 4 by 2 rectangle and a 4 by 3 rectangle? Well, that actually works, right? So that would be exactly what we're looking for. If we were to split this into a 4 by 2, that would be our 4 times, or I'll write it in the same order. 4 times 2 would be the area of this portion of the rectangle, plus 4 times 3, right? The height of 4 and width of 3. And again, we're splitting this big rectangle into 2 rectangles. And does that give us the same area? Well, 4 by 2 gives us 8, and 4 times 3 gives us 12. So 8 plus 12 gives us 20. Would that be the same if we just looked at the original, oh my goodness, 8 plus 12 makes 20, there we go. Now if we look at the original shape, the area should match up regardless of how we split up this rectangle. So the height of 4, but an entire width of 1, 2, 3, 4, 5. So this is a way we can check it. So what if we did 5 times 4? That would indeed give us 20, okay? 5 times 4 gives us 20. 8 plus 12 gives us 20. And if we look at this, what did we change? What would we be factoring out, which is what we're going to learn about down the road, is the thing that we're doing is we're doing 4 times 2 and 4 times 3 when we split this up. Okay? Isn't this the same as if we did 2 plus 3 times 4? Right? And we see that 2 plus 3 makes 5. So that's all we're doing. And if we were to put these together and distribute this 4 using the distributive property, we would have 4 times 2 plus 4 times 3. Again, equals 20. Alright, so let's go on to the next one here, and let's see which of these scenarios would make sense. So 5 times 3, 5 times 2, and 5 times 5. So can we break this? If we break off a 5 by 3 piece, okay, so we break off a 5 by 3 piece, cover that much up. Let's get a paper. So we're going to remove 3 of the blocks, right? Boom, boom, boom. And then we remove another 2 blocks, another set of 5 by 2 rectangle. Boom, boom. Do we have 5 rows and 5 columns left? We do not. So we know that that's not an option. But this one. So we're going to bite off a 5 by 2 rectangle. Gone. 5 by 1 rectangle. Gone. Now do we have a 5 by 4 rectangle left over? Height of 5, width of 4. And yes, that's exactly what we're looking for. Okay. Another way to think of that would be 5 times the width of the rectangles we broke off was 2 and a 1 and a 4. Okay, and if we add those together, 2 and 1 and 4, we should get 1, 2, 3, 4, 5, 6, 7. So the original dimensions would be 5 times 7. And what we did is we used, again, the distributive property to essentially break apart the width of this 7 into 2 plus 1 plus 4. All right. Great job. Let's try another one. These are actually a little bit clearer because it probably makes sense that we're going to break this rectangle into 2 areas of 1 times 2 and 2 times 1, 2, 3, 4, 5. So do we see a 1 times 2 and a 5 times 2 somewhere? That would be this, right? 1 times 2 equals an area of 2. 5 times 2 equals an area of 10. Add those together and we get a total area of 12, okay? Now it's not asking for the total area in this case, but rather how we would break that up. 1 times 2 is 2, plus 5 times 2 is 10. And that was a way to check our work there. Okay, next one. This again looks like it's pretty easy to break these into 3 rectangles. So it looks like we're looking at 1 times 2 and 2 times 2, and then this big rectangle on the bottom would be 1, 2, 3, 4, 5. 5 times 3. Okay, so we're looking for 1 times 2 plus 2 times 2 plus 3 times 5. We see that here? 4 by 4. I don't see any 4 by 4 sections, so that doesn't make sense. 5 by 5. This wouldn't make sense if we were talking about where we didn't have those pieces bitten off of our, maybe this is a candy bar. So 5 by 5 would work if there was no pieces missing, so that's not going to work for us. 4 by 5, that doesn't make sense. Hopefully this one works. 1 times 2. Here's another 2 by 2 block to satisfy that. Now what about a 5 by 3 block? 5 by 3. And that's our correct answer. Good job, everyone. See you next time.